Hello, welcome to the ARM Dev Summit 2021. My name's John Moore. I work for Ford Motor Company. Today I want to talk to you about automotive cybersecurity, driving towards a trusted vehicle architecture ecosystem. Before we can talk about what trust means for the vehicle, we have to understand what we're trying to accomplish with this talk, right? So ultimately, our goal here is to look to what it would mean to formalize, build, standardize, and validate architecting trust into the vehicle in a way that's testable, repeatable, verifiable, and certifiable. This is especially important with the onset of new legislation for automotive compliance, including ISO 21434 and UNECE WP29. In order for that to occur, we have to think about where we're coming from to understand where we're going to. And so the first thing that we should think about is trust is more than just the modules and the interaction of those modules. They also have a human component. They also have a cloud component. They also have an edge component. So if we distill all of those processes down, we have a set of goals that we can lay out from a security standpoint, which we have 7 of them, of which to help with cyber assurance. And cyber assurance comes from information assurance. These are the pillars which we want to stand on. I think of it like this. So you could think of it as having 7 light switches in a room, and each one labeled with each of these vectors, right? And we'll make them dimmer switches. And your goal is to make the room as bright as possible. So we want to turn them all the way up, all of them. So at all times, we are trying to create a security environment that maximizes or optimizes the lighting in the room, right? So now what's new to that and why it's Assurance Plus is that we have a compliance aspect. So we have to look at traceability, and wouldn't it be great if trust could be extended all the way through the system to give us assurance that that the IoT device or group of IoT devices or something like a vehicle is doing what it should be doing, computing with the data it's expected to, and has trust that goes back to its roots. Now, what's interesting is that this is all part of an ecosystem. So at the beginning, we may not just be authorizing data or modules or compute, we may be also authorizing people. So we want to make sure that we have that we can avoid what I call the evil twin problem. And the concept is you're born, you have a twin that looks just like you. If you have something you are, I would say a face scan, and that's used to allow you to say drive your car. Could your twin brother or sister get in the vehicle and drive the car as well, right? And that's because this is a weakness with single factor, is that in a twin scenario, even known rare, is not make that individual unique. So you have to group factors together to get strong authentication. And what you would do there is you could say, all right, well, I don't want my brother to drive my car, so I'll have a knowledge challenge, just like with an ATM, where I have to put in a PIN number. If they don't know that PIN number, you've just added something you know with something you are, and you've achieved multi-factor security. Now, what's very interesting is Ron Rivest also came up with a system that's reputational based called Someone You Know. This isn't used a lot in multi-factor. It's almost always something you have, something you are, and something you know, but it also can be someone you know, right? And if you think about how we work as a society, sometimes we trust a friend and then trust who they trust through a transitive property, right? So this is something that could play into making sure that we're authentic to start with, a human root of trust to build the data root of trust and the compute root of trust that follows after it. We also want to assume that what we know about trust is trust should be earned. It should not be inherently given. And in security, many exploits or many problems come from that abuse of inherent trust. So the industry is trying to move towards what's known as a zero trust model, which means that we have to build trust between the components versus have assumed trust that could be, possibly abused, right? And there are groups in the IoT space that do it, like the Trusted Compute group. However, we don't really have this to the same degree for vehicle-based trust within the vehicle. So in the slides to come, we're going to explore what that might mean and what it might mean for all OEMs to come together to standardize this to make it more economical for everyone involved. And last on this slide, just really talking about these type of interactions we talked about in the system are coming from inherent trust and inherent trust profiles. So, you could have a inherent protocol that, say, is on your phone and maybe is able to be picked up by your vehicle, or maybe the vehicle can talk to a roadside unit, right? So there could be multiple interactions and multiple ways that you can obtain trust on the vehicle within the ecosystem. So that being said, what does that look like from an architecture perspective? So how do we build trust within the vehicle? All right, so really that starts with a trust anchor or a root of trust. And what this is just some secret. Think of it like a seed, and then you plant the seed, and that seed grows a root, and then that root will grow into a plant, right? And ultimately, it's always based on that seed, right? So the key is we want to start with a secret that we keep safe, and then we create derived secure processes from that allow us to extend it to the next level. So for instance, we could start off with a root of trust that could extend into our secure boot, which then we could use that to extend it into a chain of trust to the modules or devices. And then finally, we could also then take information from that and encode it into our logging and diagnostics so that we can validate from the beginning of its journey all the way to the end of that journey, right? And that's something that's really great for compliance because then we can say, hey, look, we've seen that we have an integrity check from the beginning of this to the end of that. And if that integrity check's in place, then we have trust it wasn't tampered with. So we get some advantages from that type of structure. So if you think about it, no industry standard for established root of trust today or chain of trust or secure boot for automotive IoT. So there are some groups beginning to form, but there is no agreement on what that process should look like. And when that process becomes standardized, then it's really nice because you can use certification and external certification to give you even more trust in the system. So it's a very interesting model. Now, a couple interesting things is when we do have a root of trust, we should have a compute derivable process that allows us to use a root of trust if it's immutable, meaning it's not going to change in the system, but it's in secure memory. For instance, in like an HSM, we won't know what it is, but then that key material can derive other keys that could be revoked, reissued, rotated in nature. So we're not directly revoking a root of trust, but we're creating processes that allow us to revoke root of trust. And that way, if there is some type of issue, we can make it. We can make those changes if the foundational capability is available. Right. And that's sort of the drive here is that we're trying to say, how can we architect something that gives us foundational security and trust capabilities right from the start? So from building a vehicle root of trust, all right. So if we say, all right, well, if OEMs are going to standardize this, what is the minimal viable product that needs to be in the vehicle or in the vehicle ecosystem to allow us to leverage or get the most out of things like ARM's, PSA APIs or the crypto specification. So for that to occur, you want to make sure that you have public key cryptography operations, computing hash functions, key management, and generation. That generation should probably rely on a strong random number generator that should be validated over time. Secure storage of keys and other data secret. We just talked about that. And if you're going to transfer that data between modules, you should think about having a trusted baseline. So sort of like ARM secure world, normal world. And then again, we want to be able to extend these root of trust or the trust of the vehicle into the compliance management. So, it should be an integrity process that we can validate. And then we can use that integrity to say, yes, we have trust that this thing did what it was supposed to do. And we can build that into things like attestation tokens, which we'll talk about in a few slides. So we talked about that compliance will require compliance management, right? So some best practices that we can think about that could help here or could be included in some type of industry, root of trust study or research is that you should think about unifying a government system and having a centralized way in and out, right? That makes it much easier to control access into it, as well as making sure that you don't have a fractured system. As we move towards platform-based compute, APIs are amazing, right? Because now we have the code that says what we can put in and what we can get out. And we can share that with our governance teams to say, hey, is this something that we want to allow or something that we don't, right? So there should be the process of the API reviews in the standardization, right? That is a useful aspect. Um, Another that could be helpful is some of the platforms that are moving forward with OEMs will allow the use of software-oriented architecture, right? So, for instance, things like some IP or DDS have some foundational capabilities. What I like about DDS is DDS allows you to manage based on topics. So, what that means, if you have, say, a topic like I will call it, you know, confidential, right? So let's say somewhere on the vehicle you're taking in credit card information, right? You could label that topic, and then you would have um, set processes of how to deal with that from an access control standpoint and from a compute management standpoint, right? So, for instance, you could make sure it stays encrypted at rest and in transit by managing by topic, right? So that's a powerful tool to help with that aspect. Allows customization and dynamicism for an ever-changing compliance regulation landscape. Whatever tools you use for management, make sure they're highly flexible, right? So as OEMs come together, maybe there'll be one system, maybe there'll be multiple systems, but you want to be able to handle the changes because there's the impending regulations and compliance will require us to have something that we can get traceability out of, right? And the easier we can make that with like one-to-one mappings or one-to-many mappings will make that job a lot easier. You should be able to manage these systems that can implement a hierarchy that mirrors one's organizational structure. We see this a lot with like Microsoft and Active Directory. You can use Active Directory to mimic that structure. Whatever system you use here, there should be similar ability to handle flows. And as we start moving to a world where we think about APIs more than module-to-module communication, we realize that we're decoupling and abstracting away um, the process from the hardware. And this really could be a big save, right? Because if we can retire systems without having dependencies cause issues for us, that's really big, which means that we can stand up new services as long as they know how to work with the APIs and new systems, and we can retire the old ones without any disruption. Why do we even care about a vehicle root of trust? Now, what a vehicle root of trust to me is a group of trust, right? So you've extended root of trust in through a module, but now you want a module to trust a series of modules. So for vehicles, that could be like a central gateway, and then every module attached could be one of that group of trust, right? And if you could get data from just that node, it would be much simpler than having to query every node in the system. So when you start thinking about what do we get from having a vehicle root of trust or a group of trust, you can think about some of the things that could help with building foundational capabilities within the vehicle, right? So we could do unforgeable identities for the vehicle, right? And this could be good for like think of interacting with the like roadside units or V2X, right? So if you're talking to other vehicles on the road, or you want to be able to see past a corner and have that corner tell you that there's a car broken down on the other side, you want to make sure that you're unique, and that maybe that someone isn't trying to come in and spoof the system and look like you. And that could help with that type of integrity by reducing that confusion, right? Secure onboard key provisioning, so we can tie root of trust in with that process. ECU discovery and manifest building. We just talked about SOA and software-oriented architectures. There's service discovery that sits with that. So again, you could have, it's sort of like you could have a unique value in the SOA system and a unique value from root of trust, just to make sure that no one hasn't cloned that device and made it look like the original. A vehicle logging attestation. So like we said before, what if you have something like an autonomous vehicle and it has an error and you want to know whether that error is a bug or it's been tampered with? if the integrity is in place, you'll have the ability to infer that it probably wasn't tampered with and therefore would be a bug. However, just because it's tamper evident doesn't mean that we can figure out attribution, right? We don't know exactly what happened. It's sort of like when you buy aspirin at the store. If you open it up and the foil seal is broken, then you would think not to ingest any. However, you don't know what broke that seal, right? So that's how we have to view trust here. If trust is present, we should think about trusting it. If trust is not present, we don't know exactly what happened, but we do know in some form there may have been tampering occurring, right? And same thing with diagnostics. We can bring diagnostics in the same way. As we start thinking of remote diagnostics, wouldn't it be great to say, is this authentically the vehicle, or is this authentically the diagnostic tool that I'm talking with, or remote connection? So a lot of good use cases that could help build foundational capabilities for teams and for OEMs. So where would you architect this, right? So where do you put this group of trust? So you can create a group of trust that can be implemented against an app. It can be thrown against a partition, a secure partition, and you can use HSMs or TPMs or SHEs to help you keep the root of trust safe to derive these processes, right? So effectively, we just extend a chain of trust or create a group of trust into the platform root of trust. Modules association can be unique per vehicle. We discussed that. Manage the assets has greater assurance. If we see, if we have trusted tokens starting at the beginning, coming all the way up through logging, we would have the warm and fuzzies that everything's working as it should. Again, doesn't mean everything's working correct, but it reduces the likelihood of tamper. From an ARM architecture standpoint, what can we leverage to enhance and shorten the development time, right? Here's one of the really big wins for the industry is that if we can utilize existing mechanisms, like with ARM's PSA libraries, we can develop this much quicker. And so we can save time and money through that process. Also helps with making sure we engineer it properly, because we have models out there that help us to put that implementation together to hope to not make some common mistakes that occur that way. So for the VROT, we can leverage the PSA secure design. So we can think about isolation that comes with it. We can think about how we can use functional APIs. And one of the things I love is that we can also use PSA certified, which means that OEMs will not have to authorize or validate these models on their own. They can send them off to a third party to be validated, right? And so this gives us a lot of movement towards creating almost a plug-and-play security mechanisms to talk between modules that don't start with any trust in our zero trust model, right? So we get the advantages of robust implementation, software portability, certified quality. Again, we talked about the development cost, and like I said, where we can realize more cost is that if the industry is able to work together, all OEMs together, and understand what that that boot process will look like, what does trust architecture mean, right? And then be able to have independent tests to validate those. Okay, so let's talk about attestation, right? So you see a car on top, you see a car on the bottom left. The car on the top left is what we would expect to be genuine ECUs that were provided, by a trusted partner for the OEM. And then the bottom, we have things like, third party parts, for instance, like gray market, that are not approved by the OEM, but do function. We see there's some modules in here that they've changed the modules, so they're tampered with. We see a device that's rooted, which might do things like leak keys. We see a couple clone devices, right? So with these in place, we would be lacking some of the pieces of the attestation token. Now, attestation token can include whatever information, say collectively the OEMs come up with. So what's listed here is just a wish list or just a set of things that we could put in here, right? But ultimately, the signed token would be able to be traced back to the genuine aspects we see in the top left, right? And we'd have a relaying agent, a verifying agent that would help with that process. So that's sort of what it would look like. Again, we would have to, figure out agreement as an industry to see what those key token aspects should be, and then look to standardize it for, a safe across the industry. So other things to think about when we think about a vehicle root of trust. So you might, so if we start thinking about things like fail functional, which if we're working with if OEMs are working with things like autonomous vehicles, we may want to have a secondary root of trust. So if one module goes bad, we have a secondary, right? So there could be a fail operational expectation. So you could have multiples there. One as primary, one as backup, or you could place it in any module within the vehicle. So for instance, if all vehicles have a TCU, but not all have a gateway, again, not sure how that would work, but if that's the case, you could move these services to the TCU. So you're not limited there. So, and then also we could look to thinking about how this would integrate with life cycle management of the vehicle, right? So, maybe could we, for instance, blow a fuse at the end of life that ends the VROT's life cycle and therefore has some actions associated with it, or some other aspects that we might be able to control or achieve compliance items through that process. So, and then trust may be maintained when replacing ECUs, right? So we'll have, vehicles will get worked on, and they'll have to have their modules changed, and those will have to find a way to register back, right? So we'll have to make sure that there is a process to register and lock those changes securely. Again, we don't have a standard for this today. And then end of life, we talked about things like destruction, possibly if there's a VIN certificate, if there's one present or it's required by compliance. And then obviously, if we have new modules, we might need to reassociate them with the vehicle or with the gateway or some other factor that, again, could be defined by the OEMs collectively. For those that work with PSA that are not in the vehicle space, there's two standards that help for the independent certification, and they work towards the NIST and the ETSI standard that you see right there. But if we're starting to think about what this would mean for automotive certification, then we would want to see the certification be mapped against the ISO 21434, again, ratified just last month, and the UNEC WP29, which continues to be built out, but is active. So the PSA certified guidance for VROT service enablement. VROT can be built on top of PSA PROT services, right? So and PROT at the bottom you see is platform. So effectively, our platform itself, it differs today or will differ from OEM to OEM. So again, another standardization opportunity to look at across the industry. ARM PSA can accelerate ECU application and platform development. Also, we can also help with, or really just building capabilities in any module in the vehicle. Which, again, if you have the tools available to you, it's going to save time and money and work power, right? So, creating a VROT on top of the PSA, what do we get? Well, ARM has already thought about many of the security aspects, right? So you're going to end up with better security. Independent validated quality through the certification process, and probably lower cost through the ABI portability, abstraction, and the other things that we've talked about. So to summarize, we see that ARM and the PSA certified program help strengthen our cyber assurance posture. And when OEMs have tier suppliers that use predominantly ARM standards or ARM chips in their solutions, it is very nice to be able to have something like PSA certified to make sure that they've crossed their T's and dotted their I's during that process. So we will look forward to more of that alignment of the industries moving forward, and as the OEMs too can come together on what it means to have trust within the vehicle. PSA certified can assist with accelerating the architectural development and foundational trust, right? So what we get is we're going to get better management for compliance and governance. We're going to get better management of data classification, access control, right? We're going to get a process for lifecycle management, really we're kind of moving into a distributed architecture, which is a plug and play security ecosystem, right? Wouldn't it be nice if you could just plug into another device that you don't trust, but yet it's built in such a way that trust can be maintained between the devices, right? And that's really the overall impetus behind something like a platform security architecture that ARM has put together. And then finally, creating standardizing a VROT will result in we said it earlier, better security, uh, validation, lower cost. And what I think is probably the most important is that we'll get traceability, integrity, and trust that can be extended from the beginning of the process to the end of the process. Also, if you're looking for some interesting or very useful links, whether you're in automotive IoT or just in IoT, these are really great, useful resources that ARM provides to get you started on some of these topics that we talked about today. And with that, I'd like to say thank you. Hello, and I just want to let you know there will be a live Q&A session starting now to continue the conversation. To take part, join us on Zoom by clicking on the yellow button just below the video player on this sessions page.